Hey, welcome to video 7.4. We are graphing systems of inequalities, and I'm going to recommend that you get yourself some two items that are colored that are kind of see-through, so colored pencil, highlighter, crayon, probably not like a dark marker would be good. So I'm going to do these. All right, so first thing we're going to do is take a look at how we decide if points are a solution to a system of inequalities. So it's really similar to what you did with the previous section, except you have to put the point in both of the equations instead of just one. So for example, this is my x and this is my y. I'm going to take this, and 3 plus 8 is greater than 10. 11 is greater than 10. So that one checks out. Then I have 8 instead of y, greater than or equal to 3 times 3 minus 5. So that's 8 greater than or equal to 9 minus 5. So that's 8 is greater than or equal to 4. That checks out, so my answer for this one is yes. Okay, you try this one, pause it, put the 5 in for x and the 9 in for y on these, and then see if they work or not. Okay, this one does end up being no. The first one checks out, the x and y work, but for the second one, the x and y do not work. Okay, now we're going to take a look at graphing our system of inequalities. So it's just like graphing one equation, except this time we're graphing both of them, and we're graphing them on the same coordinate plane. So this one, I'm going to rewrite it in y equals mx plus b format. My y-intercept is 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So there's my y-intercept. And then -1, so that's like a rise of -1, a run of 1, and then we keep going like that. This one, since it has a greater than sign, is going to be a dashed line. So when I make my line, I'm going to do dashes like that. And then I'm going to graph this one, y-intercept of -5, 1, 2, 3, 4, 5, and then a slope of 3. So it goes like that. This one is a solid line because it's greater than or equal to, whoops, that one was not as straight as it could be. Okay, and then now is when we get to use our colors. So on the first one, it's y is greater than, so that means on this one, the first one, I am going to color everything where y is greater than. So here's my y-axis, and since y is bigger, I'm coloring the part where the y-axis is up at the top. And then I'm going to go on to my second one. So this one, y is also greater than, and this is where my y is bigger up here. So I'm going to color in this part. And then everything that is in the part that is colored by both colors, that's the solution set to our system of inequalities. So everything that's now that green color, since I used blue and yellow, is the system of inequality. So if I wanted to check this, 3, 8 would be in here, but 5, 9 would not be in there. That would be over here somewhere, not in that double colored area. Okay, I want you to try this one down here. So pause it, give it a try, do your colors, and then come back and see what it looks like. Okay, here's your answer for that one down there. Let's go ahead and move on to the next part. So on the back, give this one a try. It's the same thing we already did on the front. So you've got your system of inequalities, and then you're just testing these to see whether they are a solution to both of these inequalities. So pause it and give it a try. Your answer for this one is number 3 is the only one that works for both of them, and I've got all of my substitution work here so you can see what's going on if you want to. All right, let's try another one. So we're not going to worry about this. We've had some practice on that. This time we are going to look at 3 equations at the same time. Now I'm noticing that these two right here are a horizontal and a vertical, so I'm going to look at those first. Y is greater than -2, or greater than or equal to, so that's going to be a solid line where y is -2 down here. So I'm going to start there. And I'm looking at everything above that, and then x is greater than 4, so here's where x is 4, or I'm sorry, x is less than 4. I'm going to have a dotted line or a dashed line, and x is going to be less than 4. So I'm looking for everything that's above this line and less than this line. So I'm looking at this portion of my graph right here. Okay, now I'm going to look at my next line. So y equals 2x. That means we've got a y-intercept of 0, and then I'm going up 2 over 1, because that's my slope. It's going to be a solid line because it's less than or equal to. And so we're looking at y is less than, so everything below here. And so that triangle that's double colored is the portion of the graph that is a solution set to all 3 of these right here. So in this one, it wants us to find the area of this portion, and so we're just looking at this triangle. Area of a triangle is 1/2 base times height. Our base is 1, 2, 3, 4, 5, and our height is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So 1/2 times 5 times 10 is 25, and that's square units. And this one says, why does the dashed line in one of the borders, this one right here, not make a difference in terms of the area we found? Because we're not talking about perimeter, how long it is around and whether that's included or not. We're talking about the area, how much is on the inside, and the boundary, whether it's included in the boundary or not, does not make a difference as to the area on the inside. Okay, please write down any questions that you have for me, and we'll talk about them in class.